Hello all. Today we are solving LeetCode problem number 1727, largest submatrix with rearrangements. So you are given a binary matrix called a matrix of size m cross m, and you are allowed to rearrange the columns of matrix in any order. So only columns you can rearrange in any order. Return the area of largest submatrix within the matrix where every element of submatrix is 1 after reordering the columns optimally. So this is the question. So based on this example we can understand what exactly is the question and what exactly the output is. So we are given a matrix which is m cross n, so this is 3 cross 3 matrix, and we can rearrange the column. So this is the column, so we can rearrange based on our needs. So now we have to return the largest submatrix within the matrix and its area. So from here we can see that the submatrix can be a rectangle or a square. So ideally this should be a rectangle. So in this case, from this matrix you can note this forms area of 3 having all ones, and this particular submatrix forms area of 4. So 4 is the maximum area which could be formed out of this matrix, and that is what exactly we are returning as the output. And we can note that this is the given matrix where you do not have any uh, area of 4 submatrix present within it, because after rearranging this, putting this particular column in the 0th position, you will get this particular submatrix. So from this you might get an idea that we can use sorting and sort the column. So how we can calculate number of ones, and based on that we can descending order sorting. So with that you will get something like this, because you have from this 0th row you have 2 ones, and the first row you have 1 1 and 3 ones. So now you have 3 2 1, which could be of, let me draw this completely. So you have 3 rows and 3 columns. So you have 1 1 1 here and 1 1 here, and the last one is 1 here. So out of which you can see that this is the biggest submatrix which we could form. So the matrix could be rearranged in this way and we can calculate the area. So now here comes the tricky part actually. So honestly I could not able to figure out to calculate this area, because we have to track the number of ones for height. So finding height is a problem. In terms of width you have 0 indexed matrix, so 0 1 2 0 1 2. So width you can use the index which is I or j, or no, this should be width, right? So in this case you need the column 1. So based on that this should be j. So j plus 1. So that is how you determine the width, right? So if this is a width which is of size 2, you have the j is equal to 1 here, because you will be standing at this position, and now 1 plus 1 is nothing but 2. So you got the when you get the width of size 2. So this is how you calculate width. But in terms of height, that varies, because you have to track everything column by column. So you have 3 columns in total, and you will have 3 different heights. So this 3 different height also will vary based on the rows. So if we consider only this row, you have only 1 here and 0 0 here. So here if you are considering this, you have 1 0 0 at row 0, and coming to this you have 2 1 and 1 at row 1. I think this should be written separately. Yes, and sorry, this should be 2 2 1 1 at row 1, and 3 2, this is 0 at row row 2. So now you can see the difference because you have various height, and based on that you have to calculate area and you have to calculate width, and using that you have to deal with this height, this height, this height, and this one, this one, this one, and you will be doing repeating this until the last height, right? So this is the tricky part. So how are we going to solve? We will be using an array, which we can call it as accumulated sum array, which is of size column, so column size. So here it is 3, and so hence you will have 3 initialized as 0 0 0, so 3 you have. And now what you do is you will be filling by we will be processing by row by row, as I said. And if you encounter matrix of I and j equal to 1, in that case you will accumulate the sum. So you will increment the matrix or accumulated sum of j will be incremented by 1. And if matrix of I and j is 0, then there is no accumulated sum incremented or the sum remains same. This will be updated back to 0. So accumulated sum of j is equal to 0, so this is assigned back to 0. So that is how you will be filling it, and then you will be using the column size column to calculate width and then area. So we can look into the example as to solve or give a run through this function. So you have 1 0 0 and 1 1 1. So now what happens here is at row 0 you have 1 0 0, so this is 0 1 2, and now you have the accumulated array as 0 0 0. So hence this is 1, this will be updated as 1, and this remains 0. So now area or result will be equal to 0 first initially. So now you have 1 here, and this is 0 plus 1, you get the area as 1. And here it is 0, so 0 multiplied by 1 plus 1 is 2 is 0, and 0 multiplied by anything is again 0. So in this first row you get the area as 1, and now at the second row, when you are coming to second row, you have 1 1 and 1. So this is row 1. Now you can see here the next matrix, I mean the next the matrix value here is 1, and in this position it is already 1, so accumulated value this becomes 2, and 1 here as well, so this is updated to 1 and 1. So what happens here is this array gets updated to 2 1 1, and now 2 multiplied with 0 plus 1 2 multiplied with 0 plus 1 based on the index you are getting the width, and this is 2. And now again 1 multiplied with this 1 multiplied with 1 plus 1 1 plus 1, which is again 2, and a 2 it is. and again 1 multiplied with this is 2 plus 1, so now you get 3, so this is updated to 3. So this is how you continue, and we move to next row where you have 1 1 0. So now what happens here is you have one more 1 here, so this will be updated to 3 and this will be updated to 2. Now you encounter 0, so this is updated back to 0. So the new array, accumulated array, is 3 to 1, I mean 3 to 0. So similar calculation, now you will do 3 multiplied by 0 plus 1 is 3, so 3 it is here, and the next one is 2. 2 multiplied by 1 plus 1 is 4, so you update to 4 here, and the last one is 0, so 0 it is, and we are end of iteration and the area is 4, you return area equal to 4. So this is the output and this is the answer. And time complexity for this is, since we are using the sorting, we will have log n times, and since it is matrix, so it is big O of n cross m log n. So this is the time complexity. So with this idea, let us go ahead and code this up. So we start with n is equal to length of matrix, and m will be length of matrix of 0. So I'll copy matrix. So since these two are done, we will have accumulated some list. So which is equal to initialized with 0 times m. So based on the column size we are having this, and result will have the actual area, the output area. So now for I in range n and for j in range m, so now if matrix of ij is 1, which is if it is 1, so you will have accumulated j value increment by 1. So accumulated sum array of j will be incremented by 1. So now else this will be updated as 0 only. So accumulated sum of j is equal to 0, so assigned to 0. So now this is done. Now it's time to create an array by which we will pass in this accumulated sum array, and we will reverse it based on, because we need the descending order. So s is equal to sorted, where we pass in accumulated sum and reverse is true. So now this is done. Now we will iterate through this, and we will use this max function to get the maximum result out of it. So now for column in range, you have length of yes. So iterating this, now result is equal to max of existing result, and now s of column multiplied by column plus 1. So now this is done. We have the result here and return result. So this is the entire code. Let me run it and submit it, and there you go. Thank you.